Okay, sorry I haven't been putting the homework up. I've been sick this week and been leaving work a little bit early. I hope this doesn't set you back. So this one was going to be where we're making fractions into smaller units, making equivalents, and here we're always going to be using multiplication. So you can see here that you had 2/3 shaded. We're looking simply at these boxes. So 2 are shaded out of 3. Then you can see they did this horizontal cut and then made 6 boxes with 4 shaded. The math work for that is multiplying both the numerator and the denominator by 2. We cut each of the sections into 2 equal parts. So the 2 that were shaded became 4 equal parts. The 3 total became 6 parts. So you're going to write the original fraction and then think about what you visually see mathematically. So in B, you're thinking about the original fraction. You can see here that it's 3 out of 4. And they're cut into 2 equal parts. So you can see that you're going to multiply both the numerator and the denominator by 2. Remember that any fraction with the numerator and denominator is the same number is equal to 1 whole. We're not changing the fraction value, we're finding an equivalent fraction. So this becomes 6 out of 8. You're going to go ahead and do C and D. Then when you come down to 2, you're going to look at the fraction that you see and make an equivalent. In this case, you're going to make them equivalent to 12ths. So you're going to think through the problem by making the fraction you see, in this case it's 3/6, and asking yourself, how many 12ths is that? And in this case, you see 2/4, and you're going to ask yourself, how many 12ths is that? So you're going to have to think, what are you multiplying by to get 12? Whatever number this is, you're going to use in the same number on the top. However many things you cut the 6 into, the 3 that are shaded will also be cut into, is one way to think of it. Here, how do you get from 4 to 12? You're going to multiply, and then you're also going to show what that looks like by cutting the tape. On these, you're going to draw a tape diagram to prove they're true. So what I like to do for these is I like to draw the original and show with a bracket above what the fraction is. So here we have 2/5, so I'm going to shade it in 2/5. I'm going to label that at the top. This is 2/5. To show 4/10, I know that I have to make 5 and double it, and 2 and double it, so I'm going to cut it in half. And then this same amount, even though it's 2/5, is now 4/10. This is a way to use an area model to prove that they're true. Here, you're going to do multiplication to create equivalent fractions. Remember, when you multiply any fraction, you want to multiply by 1 because that's going to equal the same number. 1 can be represented as a fraction as 2/2, 3/3. You see the pattern. Any number over itself is 1 whole. If I draw something with 2 sections and 2 are shaded, it's the whole thing. If I draw something with 3 sections and 3 are shaded, it's the whole thing. So you can pick what you're going to multiply each fraction by, but remember, what you multiply by should be the same number in the numerator and the denominator. That's going to create an equivalent fraction. Question 5 is what we practiced in class today. Checking to see if they're true. You can do that by asking yourself, how do you get from one fraction to the other? It's through multiplying. So in this case, I'd ask myself, how do I get, if I look at C, how do I get from 3 to 6? Well, I know that's times 2. Two times bigger. How do I get from 5 to 15? Well, that's 3 times bigger. 2/3 is not equivalent to 1 whole, so these are not equivalent. That would be false. Let's check this one. From 7 to 21, I multiply by 3. 4 to 12, I multiply by 3. 3/3 is equal to 1 whole, so these fractions are equivalent, so that would be true. Remember, correct those that are false by changing the right-hand side of the number sentence. So in this case, 3/5, you're going to make it equivalent over here. So find an equivalent fraction.